You know, secular scientists seem to think that with our biblical worldview, we can't explain a lot of things. Well, let's try them on the woolly mammoth, which I'll tell you a little more about right now. In fact, what is a woolly mammoth? Woolly mammoth is essentially a hairy elephant. It had a cousin called the Columbian mammoth that generally lived further south in the United States. It had three types of hair. The longest is 1 meter or 3 feet. It had spiraling in tusks, hump on its head, hump on its back, and a sloping back. It's closest to the Indian elephant today. And it lived generally in the northern part of the northern hemisphere. In fact, it was common in Siberia. This is where you find them by the millions. Let's take a little geography lesson in Siberia. Here's the Ural Mountains, and that starts Siberia. This is western Siberia, which is very low. This is color-coded by altitude. Green is low altitude, brown is high altitude. So you have a lot of woolly mammoths, especially closer to the Arctic Ocean. And in Northeast Asia, you have higher areas, but the woolly mammoths, a lot of times were in this low area close to the Arctic Ocean. Here's the New Siberian Islands where there's a lot of mammoth bones. And on the continental shelf out here in covered by the ocean, you find lots of mammoth bones buried in the sediments of the continental shelf. So that's generally where you find them, and it's in that area. Anyway, there's a number of mysteries associated with the woolly mammoth. Oops, went the wrong way. Number one, bones and tusks are found in permafrost up there, which is permanently frozen ground. Their bones and tusks are generally well preserved, implying that they were buried rapidly. Also, you find some actual carcasses, whole flesh with stomach contents, which, how do you get them jammed into the permafrost, which is rock hard? It only melts in the top 1 or 2 feet in the summertime, but below that it's rock hard. How do you get those woolly mammoths down into that permafrost? A major mystery. Also, its stomach contents are only half digested, suggesting being frozen rapidly. Now here's a quote from Henry Howarth about the mystery of getting the woolly mammoths in the permafrost. Now, by no physical process is known to us, can we imagine how soft flesh could thus be buried in ground while it's frozen as hard as flint without disintegrating it? We cannot push an elephant's body into a mass of solid ice or hard frozen gravel and clay without entirely destroying the fine articulations and pounding the whole mass into a jelly, nor would we fail in greatly disturbing the ground in the process. How did all these woolly mammoths, and not only woolly mammoths, you had bisons, horses, woolly rhinos, cave lions, and a huge amount of other animals, but especially woolly mammoths. How did you get them in the permafrost? Well, why did they live there? There's a number of questions. I'll get into these a little more. First of all, how many woolly mammoths are we talking about up in Siberia? I'm focusing in on Siberia, by the way, but the same applies to Alaska and the northwest Yukon territory. So if we just have a few woolly mammoths up there, you know, it's no big deal. You can explain that as they just wandered up there and died. But if there's millions, boy, it's a major mystery of Earth science. Well, to find out how many, I went to the experts in Siberia who do the research. And based on their estimates, there's many millions of mammoths still interred in the permafrost. Many millions. So we have a major mystery on our hands that's been known for over 200 years. But that's not all. Like those Russian dolls, you know, you open up the big doll, comes another doll. So there's mysteries and mysteries and mysteries, as I will show. Some more mysteries. There's a wide diversity of animals, as I have already indicated. Some of these mammals burrow, like the beavers. No, burrowing mammals and beavers. The burrowing mammals are badgers and ferrets mainly. I mean, what would they be doing up there burrowing into permafrost? maybe there wasn't any permafrost when they were up there. Maybe we ought to think about that. And most of these mammals were grazers. They ate grass. Grass is rare in Siberia today. It's mostly bog vegetation because the top, like I said, 1 or 2 feet of the permafrost melts and it pools. It has nowhere to drain. So you form all this bog vegetation, and bog vegetation is toxic to grazers that ate grass. Also, they were healthy. Wildlife specialists would consider them well-dressed giants. Most of these large animals went extinct at the end of the Ice Age, which is another major mystery of Earth science. But some mammals now live much further south, which is much warmer, which is kind of a hint that maybe it was a lot warmer up there during the Ice Age. What do we deduce from these animals? We deduce that it was a grassland with a wide diversity of plants. You need a wide diversity of plants to feed a wide diversity of animals. That means the soil was fertile, unlike the bog vegetation today. It's a high-quality habitat, light competition, long growing season. Oh, that is quite different environment than Siberia today. And that's not all. That implies the snowfall is light and melts early. You have milder, relatively dry winters. Summer bogs are rare. That means little or no permafrost until the end of the Ice Age. No permafrost. Well, the secular scientists believe permafrost has been there for millions of years. And some more evidence that there's no permafrost is the distribution during the Ice Age of the saga antelope. The saga antelope, let's see, my cursor work? No, it doesn't. Anyway, I'll have to describe this to you since I don't have oh, you have one of those pointers? Yeah, I need a pointer. See, when you have 2 screens, it's good to have a cursor that can point to both screens. Anyway, the distribution of the saga antelope today is that solid line. Historically, it was a larger area. That's the dashed lines. But during the Ice Age, they lived in all those dotted areas, you see. Central Siberia, northern Alaska, lowlands of Alaska. So we'll just push this. Okay. And the northern Yukon territory. Now, the significance of saga antelope is they have small hooves, and they can't live on permafrost. They need wide open plains, grassland with no permafrost or very little permafrost. Again, reinforcing the idea, no permafrost. An environment with no permafrost up there is a radical environment. By the way, I'm getting a lot of these deductions from the secular scientists. Dale Guthrie, the University of Alaska in Fairbanks, and he wrote a book called Blue Babe that describes a bison that they unearth. But that's not all. Let's remove another part of the doll, and we see more mysteries. Some of the woolly mammoths are standing upright, as if they sunk in a bog. But unfortunately, you don't find bog sediments around the carcass or the bones. 5 animals we know of suffocated by the quality of the blood in the carcass. Some of the bones are broken. Some of them are big bones, like the pelvis, are broken. And on the New Siberian Islands, there's a lot of bone beds. In fact, they go to those islands especially to look for mammoth ivory. In fact, a lot of your piano keys probably have ivory from woolly mammoths. Also, the lowlands of Siberia and Alaska were never glaciated. Another major mystery. Some backup for the standing position. Brandt was an explorer, an Arctic explorer of a few generations ago. He said, Tolmachov, in Transactions of the American Philosophical Society, said Brandt was very much impressed by the fact that remnants of the mammoth, both the carcasses and the skeletons alike, sometimes were found in poses which indicated that the animals had perished standing upright as though they were bogged. And like I said, most of the time you don't find the bog sediments around these animals. Something else happened. Here's an example. This is the Beresavaka mammoth, found about 1901 in northeast Siberia, and that's his position he was found in, a general standing, sitting position. And here's another one, the Siberian horse. And the way this works is that they discovered the hooves of this horse sticking out from the roof of a gold mine. And so they put their lanterns on the hooves so they can light their way in the, the mine. But then the paleontologists found out about it. We want to know more about it. And then they dug him up and found out he was headless. So Dale Guthrie thinks that he sunk in a bog like this, and his head was sticking out, and a cave lion came and ate the head off, like that, and then more sediment was piled up to where it was 26 feet under the ground. It's, you know, I'm pretty sure it's not bog vegetation around it, but some other sediment, which is very key to explaining why they went extinct. And here's a schematic of the lowlands of Alaska and Siberia being unglaciated. The yellow is unglaciated, the red is glaciated. Only the mountains areas were glaciated. And you find the woolly mammoths in the lowlands and the yellow areas. They're not found in glacier ice, they're found in permafrost. There's rumors going on that they're found in ice. They're not, it's in permafrost. It is found in soil that's been frozen solid and permanently. In fact, that show you that it's a mystery that the lowlands were not glaciated. See, they run these climate models. This is in my field of atmospheric science, and it's tough to glaciate, real tough. But if you decrease the solar radiation far enough, finally you will get glaciation. That's what these two researchers did, reported in the Journal of Climate. So they did get glaciation, and notice what they say there. Now we have glaciation. It sounds like they were celebrating. But mainly outside the area where it existed during the last ice age. Oh, the lowlands in Siberia and Alaska. Okay, they have lots of problems with this. So it's a major mystery why the lowlands of Siberia and Alaska were not glaciated during the ice age. So the woolly mammoth extinction is a major mystery of mainstream Earth science. It's been that way for 200 years. Here are a few people that admit it. Back in 1929, Tomachov said, "We must explain the extinction of an animal which was living in great numbers, millions of them, apparently very prosperously over a large area in variable physical geographic conditions to which it was well adapted and which died out in a very short time, geologically speaking." How'd that happen? Peter Oard of the University of Washington, in the book called The Distant Mammoth, says, "This great extinction, truly a mass extinction," yes, it's a mass extinction. On North America, 70% of large animals over 100 pounds went extinct at the end of the Ice Age. It represents one of paleontology's most fundamental mysteries. Larry Agenbrod and Lisa Nelson. Larry Agenbrod is the chief expert on woolly mammoths in the U.S. In their book, Mammoths, says, "Why did mammoths disappear from the earth? This question remains one of the great unsolved mysteries of the past." So it's a major mystery. And there's lots of theories over the last couple hundred years. And here's a general category, 3 general categories of mysteries. Uniformitarian, that's slow processes over millions of years, slight climate change, this sort of thing. That's how they explain all the geology of the fossils, by this principle. How many of you heard of uniformitarianism? You give me a better one?
This is the green button.
Yeah, okay. Anyway, let's go on. And there's a non-creationist catastrophist, Immanuel Velikovsky being one of their chief ones. I don't speak about these guys anymore because when I poll audiences, I find out that no one's ever heard of these guys, or maybe very few. And then 3, there's us, creationist catastrophists, that want to explain it. And we generally fall into 2 camps. One group believes in a quick freeze early in the flood, Another group believes they died out at the end of the post-flood rapid ice age. I since have found out there's a third position. They died out at the end of the post-flood rapid ice age by a quick freeze. That could be kind of close. I don't think it was a quick freeze, as I'll talk about soon. Anyway, the uniformitarian hypotheses sometimes downplay the number of mammoths. They generally don't tell you, but you go to the Russian experts and they'll tell you there's millions of them. Maybe a little warmer during an interglacial. Well, if that's the case, the summer bogs are going to be a lot worse. Or maybe they lived during a colder phase of the last ice age or in previous ice ages. By the way, they believe in 50 ice ages in what's called the Pleistocene, the last 2.6 million years. 50 of them that regularly repeated. But the thing is, if it's colder, and you know, it'll freeze the bogs, and they can walk on them a lot better, but what are they going to eat? So here's a quote from Science, from a uniformitarian scientist. The woolly mammoth data can be adequately explained by the everyday processes which we can observe around us. See, it's business as usual, present processes over millions of years. They don't see the implications that this was catastrophic action. This is very unusual climate. And when this especially is emphasized when you understand how much an elephant drinks and eats. 400 to 650 pounds of feed a day, 35 to 50 gallons of water a day, and that would be similar to the woolly mammoths, which are generally hairy elephants. So they got a lot of mysteries. So that's the uniformitarians. I'm not going to speak of them, like I said, because no one hears them. They got wild ideas like the crust of the earth shifting on the mantle from a tropical climate to a cold climate, freezing them instantly, this sort of thing. But I'm going to focus in on our controversies. By the way, in earth science, we have a number of ideas on various aspects, especially the flood. But this is not a problem because there's not enough data to make a decision. So it's good to have a lot of ideas out there. And with time, you winnow these ideas. And so that's how it should work. So we have two main theories. And I'm going to talk about the quick freeze early in the flood. The way this works is woolly mammoths were peacefully eating grass and buttercups. You know, they find buttercups in their stomach and in their teeth. That's why buttercups are kind of emphasized. And suddenly, from a warm climate, the temperature dropped down to minus 150 degrees Fahrenheit below zero almost instantaneously. And this happened early in the flood somehow. That's the theory. But there's lots of problems of that. I'm going to take it in two parts. First of all, there's evidence against a flood death, and secondly, there's evidence against the quick freeze. So, evidence against a flood death. They're part of a post-flood Northern Hemisphere steppe community. This is a grassland community that during the Ice Age went all around the Northern Hemisphere in the mid and high latitudes. I'll show you a picture here soon. They're drawn on cave walls in the Ural Mountains right next to Siberia. And that's a post-flood phenomenon, not a flood phenomenon. The drawing is, that is. The cave, I believe, was formed during the flood. They're generally absent in glaciated areas. You know, so if they have nothing to do with the Ice Age, they would also be found in glaciated areas during the Ice Age. Also, this is the clincher for me when I investigated this at one time with a generally open mind, trying to figure this out. Bones of woolly mammoths are on top of glacial till. That's jargon for glacial debris in northwest Siberia. In other words, the ice occurred in northwest Siberia, and then it melted back, and the woolly mammoths came up, lived on the areas that were glaciated, and died there. So they're on top of glacial sediments. So they have nothing to do with the flood. They're associated with the Ice Age. And they're also found in surface sediments on top of flood sedimentary rocks. If they died early in the flood, they'd be way down on the bottom of the sedimentary pile, but no, they're found at the top in what was once unconsolidated sediments that is now permanently frozen. So there's lots of evidence that they didn't die in the flood. They died after the flood. Here's the woolly mammoth distribution in the red right there. And here's where it was glaciated for a long time, here in northern Scandinavia. They're not found there. You also find them in a lot of unique areas. You find them on the bottom of the Bering Sea out in here, on some of the islands in the Bering Sea that are 400 miles from the continent today, all along the Arctic shelf. You find them off the east coast of the U.S. You find them in the North Sea, but all in this red area. So they were worldwide in the northern hemisphere. So that'd be hard to explain as from the flood. And here is an example of so-called caveman, who actually was smarter than you and I, living in a cave during the rugged weather of the Ice Age. In his spare time, he would do all these cave paintings. You've probably seen a lot of them. But woolly mammoths were one of their main subjects of drawing. So they're drawn on cave walls. This is a post-flood phenomenon. It has nothing to do with happening during the flood. So there's evidence that it was against a quick freeze, down to 150 degrees Fahrenheit below zero. Why? Because there's relatively few carcasses. There's, when people think of a whole carcass like the Berisavaca mammoth, but there's less than 100 of them that have been found. And yet there's millions of them there. They're mostly bones and tusks that indicate normal dying and decay over time. A quick freeze would freeze them right in their tracks and then cover them up with sediment. So you should find a huge amount of carcasses. You find an extremely few carcasses. Also, the carcasses are partially decayed. If there was a quick freeze, they would be exceptional frozen. In fact, some people have claimed that people in Alaska have eaten mammoth steaks and things like that. As far as I know, that is not true. Dogs have eaten mammoths, but dogs will eat almost anything. So anyway, when they thaw them out, they're partially decayed already, which indicates some time occurred before they were frozen finally. Also, flies were able to have time to go in there, lay their eggs, fly pupae associated with the bones and carcasses. And here's another strong indication. When you examine the vegetation in the stomach that's half decayed, you can identify a lot of it. And you can identify the season that the vegetation was eaten when he died. And you have different seasons of death. If you had a quick freeze, it happened all at once, in one season, one instant, according to the people who believe that idea. Also, you find stomach contents partly preserved in U.S. mastodons in New England, for instance, that are found in bogs, ancient bogs. And if you can preserve them in a mastodon from the Ice Age in the U.S., well, there's not a problem for the mammoths. So there's lots of evidence against the quick freeze. So I talked about uniformitarian ideas that really have not faced up to the reality of the data out there in Siberia, Alaska, and the Yukon Territory. And I talked about the quick freeze early in the flood. How about the end of the post-flood rapid ice age? Well, what was that ice age like? Well, the ice age was started by the flood. The flood caused the ice age because of the warm oceans evaporating much more water vapor at high latitudes and volcanism from the flood and post-flood that cooled the land. So it kind of works like this. Strong evaporation at mid and high latitudes, close to where the ice built up. Volcanic dust in the upper atmosphere, snow and sleet on cold ground. So that's generally a synopsis of how the Ice Age worked. And the Ice Age covered this area right here. I could see it was down into the Seattle area. This area was glaciated during the Ice Age. In fact, Puget Sound area, Lake Washington, those are a result of Ice Age meltwater features. And generally in northern United States. I think their boundary's way too far south here, but that's another story. Anyway, here's the lowlands of Alaska and Siberia unglaciated. The mountains were glaciated. Europe and Asia, most of England, northern Germany, the Alps. This is a schematic. More mountains were glaciated in this area than I indicate. It's just a schematic to give you an idea. There's controversy on this area, how much glaciation, and now they believe the ocean north of Norway, which is very shallow, the Barents Sea, was glaciated. So that's the general area of glaciation. And based on the cooling of the ocean, I timed the ice age. There's no way to be accurate, so I use minimum and maximums for the variables. Here's the range of variables to reach glacial maximum. The best estimate was 500 years to reach glacial maximum. I'm going over this quick, and there's lots of resources that go into this that I've written. Average depth, that's the range. I use the same principle of maximum minimums in the equations. Best estimate, 2,300 feet average over North America, about 4,000 feet Antarctica. And it melts fairly quick along the edge. There's the range of values. Mainly, the main variable is the reflectivity of the snow, which in atmospheric jargon is called the albedo. Best estimate, 70 years to melt it along the periphery, but interior Canada, Scandinavia would take longer, about 200 years. So the total time for an ice age is 700 years. This is an example. See, they claim that an ice age takes, each ice age takes 100,000 years, and there were many of them. Well, this is an example where we use biblical variables, bringing the flood back to Earth history, which they rejected starting in the late 1700s. Bringing the flood back, everything occurs rapidly. Ice ages don't need 100,000 years. They can occur within about 700 years, and there's only one. So that's just a quick nutshell of the ice age, because I want to move on to the woolly mammoths dying at the end of this ice age. Well, here's an interesting thing. A guy did an experiment for the Arctic Ocean. He took the sea ice off, just took the sea ice off, but left the temperature of the Arctic Ocean at the freezing point of seawater, and then he ran his model both before taking the sea ice off and after. And this is the change in winter temperature just by getting rid of the sea ice in the Arctic Ocean. This is in degrees centigrade, by the way. On the North Pole, it warmed 40 degrees centigrade in winter. Look at northern Siberia, 20 degrees centigrade. That's 38 degrees Fahrenheit warming. It was much warmer. The upshot of this is much warmer in the winter in Siberia. And it's not going to stop a lot of animals leaving the mountains of Ararat and spreading through Siberia into North America, in the United States, and down into Central and South America, because winters were a lot warmer. But what if the temperature of the Arctic Ocean was 70 or 80 degrees Fahrenheit? It'd be even much warmer in winter in Siberia. It'd still be below freezing. And then the volcanic ash and aerosols cause cooler summers. So you'd have mild winters and cool summers in this model. And you'd have, just like in this area, you get warm onshore flow, and you don't hardly see snow. Sometimes I didn't see snow living in Seattle for 5 years. Why? Because you're close to the warm ocean. You got onshore flow from the west, keeps it warm. But you go into eastern Washington, Montana, where I live, it doesn't work that way. We have a continental climate. We get snow all the time. And so you'd have this warm onshore flow from the warm Arctic Ocean, from the warm North Pacific. It'd keep these areas mild during the winter to the point where the snow would melt in the lowlands. And so you wouldn't glaciate there, but you'd glaciate really rapidly in those mountains with all that onshore flow of moist air. So we have the model to explain why the woolly mammoths got up there. It was mild winters, cool summers. But some people ask, well, is there enough time in a 700-year ice age to produce those many millions of mammoths at the end of the ice age? Well, the way I looked at this, studying elephant reproduction, I just simply went to some of these preserves in Africa, where there's a lot of times a lot of poaching and this sort of things, and found out how fast do elephants double their population. Well, the fastest I found was in a preserve, must have had less poaching than the others. If it doubles in about 10 years, their doubling time. So if you double the elephant population in 10 years and apply it to 2 woolly mammoths that left the ark, or 2 elephants that left the ark and diverged into woolly mammoths, mastodons, and the elephants we see today, which I think is the case. See, you only have to put 2 of each kind on the ark, not 2 of each species, you see. There's plenty of room on the ark for all the animals. And I believe it was 2 elephant types that had the genes for mammoths, mastodons, and elephants. But regardless of which it is, you get finally 2 woolly mammoths, and they double every 10 years. Well, at that rate, you'll have 1.3 billion in 300 years if there's no death. And by the way, it's hard to take down a woolly mammoth, especially when there's few predators around. So this is a reasonable number. What this is telling you is that there's plenty of time during a 700-year ice age to get a population of millions of woolly mammoths all across the northern hemisphere where there weren't any ice sheets. So the time isn't a factor. What would the climate be like in Siberia during the post-flood rapid ice age? See, winters will be warmer, summers cooler, but it changes radically with time. It's a very dynamic climate. It's not. Talk about climate change. This is real powerful climate change. This is postulated Siberian temperatures with time. At the end of the flood, you had little seasonal contrast. But then winters gradually cooled towards the end, and I should have drawn this further down like this. They would actually be a fair amount cooler than today. Winters would be cooler at the end of the ice age, which is 700 years. Then they would have warmed up. Summers cooled and then warmed. Precipitation would be heavy at first, and you'd probably have forests that grew in Siberia and Alaska, and there's a lot of evidence for forests in the permafrost, but then as time went on, it'd dry out as you cooled the ocean and the ice sheets built, and you got sinking motion off the ice sheets, which were to the west of Siberia. You would dry out Siberia, and so this is the timeline for precipitation. And so by the end of the ice age, it'd be a lot drier, even drier than today, which has since recovered. Here's the woolly mammoth, the permafrost. There'd be no permafrost at the end of the flood, by definition, because the waters of the flood were warm, and the sediments put down would be warm. So there's no permafrost. So that's how you start with no permafrost, because of the flood. Isn't it interesting? You bring the flood back to Earth history, you can answer a lot of questions. And by the way, the Lord has led me to answer questions for the last 40 years that the secular people give us. And as a result, what I do and other people do, we have a lot of answers to questions that they give us in the culture. That's why we have answers books and this sort of thing out there. But anyway, there'd be no permafrost. But as winters cooled, permafrost is formed by colder winters. You would start growing, getting some permafrost. It slowly developed. And by the end of the ice age, you'd have a lot more than you have today even. And because we've warmed up since the end of the ice age, some of the permafrost would melt into hills and valleys. So that's the way permafrost works. And here's the woolly mammoth timeline. You start with 2 elephant kind leaving the ark, differentiate into 2 mammoths. They would grow slow, of course. It's geometric progression. Slow. And then it would mushroom. And then they'd spread out into Siberia, probably into here, Alaska. They'd round the Bering Land Bridge into the United States, down an ice-free corridor along the east slopes of the Rockies. And then the climate became colder, drier, windy. And then they went extinct down there. That's the woolly mammoth timeline. And here's how they got into the United States. Through an ice-free corridor early and mid-ice age. There was no ice in here. Why? Because we have west-east winds, and when you have east winds falling off mountains, it dries and warms the air. It's the same in this state, in that when you go to Yakima, Washington, which only has 8 inches a year, it's the same effect because you have downslope flow on the lee side of mountain ranges. The mountain ranges being in here, the Rockies, and the developing ice and the Cordilleran ice sheet. So you'd keep this ice free for quite a while until the end of the ice age. So that's how you get the animals into North, Central, and South America. By the way, I'm answering other questions besides dealing with the woolly mammoths. There's lots of aspects to all these issues. But let's get to the big question. You're all saying, come on, get to the point. We want to know why he went extinct. How did the woolly mammoths die in Siberia? Well, I've hinted at this. The solution to the mystery of their extinction is found in the deposits surrounding the mammoths. Are they in bog sediments, or what are they in? Sand? Oh, some are, and some are in bogs, I'm sure. But they're predominantly in a special type of sediment called loess, or loose, or however you pronounce that. And to a Soviet paleontologist said in the book, Mammoths and Mammoth Fauna, a particular interest for paleozoologists, those guys, they're the ones that study mammals that are extinct, is the Odama. That's a hill found after the permafrost melts. The hill still has the permafrost in it. This is actually a loess layer, as a rule, containing the largest amounts of remains of late Pleistocene animals. You know what loess is? It's windblown silt. They died and are buried in windblown silt. This gives us a lot of possibilities to explain a number of those other Siberian mysteries. And J.L. Guthrie, in the Frozen Fauna of the Mammoth Steppe, he talks about a frozen bison here that was killed by cave lions. Like most of the Soviet Far East, large expanses of Alaska and the Yukon Territory were not glaciated during the Pleistocene. Pleistocene means Ice Age period. Because these areas were bounded on several sides by enormous glaciers and glacial outwash streams, today much of Beringia, translated, that's eastern Siberia, Alaska, and the Yukon, is mantled with a thick deposit of aeolian windblown silt called loess. It's thick up there in the lowlands, up to 200 feet thick in some of the river valleys. So they were died and buried in windstorms. Okay, let's take a look at that. First of all, why would we have huge dust storms at the end of the Ice Age? Well, because we had colder winters. Colder winters mean drier air. That caused colder oceans. You'd have more sea ice, which would cause less evaporation. And the net result is a drier atmosphere. And the jet stream is caused by north-south temperature differences. The stronger that temperature difference, the stronger the winds aloft, as we call them. And when you still have ice sheets around and the lower latitudes are recovering and warming, you have really strong north-south temperature differences, much stronger jet stream that sometimes will sink all the way down to the surface. So you have dry, windy, cold fronts, much more than today. And that's the secret of the demise of the woolly mammoth. So I studied the Dust Bowl era. And in some days, this is what it commonly looked like. I mean, it can be calm, and suddenly a cold front comes through. Usually the winds whip up after a cold front comes through. And it can be zero visibility in blowing dust. And some of these dust storms produce huge drifts. And because of these drifts, they would cover up farms, machinery, and fences, and so forth. And it can account for a number of the mysteries right off. Why bones and tusks are buried rapidly after and during undergoing natural decay. See, each of these dust storms, I mean, you had a woolly mammoth die and decay, and he'd be buried rapidly by blowing dust to be preserved in the dust, or silt, as they call it. And this is how you get them in the permafrost, because as you pile up dust on top of these carcasses, the permafrost, which is forming from below, comes up to meet the carcass or the bones. And then you have freezing from the cold front coming in from the top. So that's how you get them into the permafrost. And that's how you preserve the bones and tusks, well preserved. And here's kind of a scene from the Dust Bowl era. How'd you like to wake up one morning in that time and look out at your house and see a dust drift that thick? Yeah, powerful. They're like blizzards that pile up a 10-foot drift and sometimes cover up to the top of your house in some areas of the United States. People from North Dakota, I'm sure, have seen this now and then. Anyways, things like this can explain the other mysteries. For instance, it can explain why some woolly mammoths are stuck in a general standing position, how they suffocated, because they suffocated by breathing in that dust. The standing position would result when the woolly mammoths were out there, and suddenly the wind came up and they turned their back to it, and the dust packs around them like a snow fence, you see, and they're stuck there. You know, blowing snow packs hard, and if you get stuck in it, you don't want to drive your four-wheel drive over drifting snow that deep. You're going to get stuck in it. If it's loose snow, you can do it. I use these examples because I've been living in Montana for 40 years, and we do such things. And it can explain for the frozen carcasses. I'm going to summarize this soon and kind of put it all together for you. But there's two mysteries left that have not been explained yet. How is the half-decayed stomach vegetation explained, number one? And how are the broken bones in some of the animals explained? Well, to do this, I find this out. I went to the book by Gary Haynes, Mammoths, Mastodons, and Elephants, 1991. The digestive system of an elephant, which is similar to a woolly mammoth, is quite different than a lot of other animals. It is based on what is called post-gastric hindgut fermentation. What that means is that digestion does not start until after the stomach, in the intestines, you see. The stomach is large, you know, probably about like that, but serves mainly to store ingested food. Enzymes within the stomach partly break down the vegetation, but most nutrients are extracted in the huge cecum and large intestine, where microbes ferment the food remaining after gastric processing. The stomach is a holding pouch, and enzymes and probably acids half break down the vegetation. So that will preserve the stomach contents for quite a while, especially in an environment in Alaska and Siberia where it was getting cold and you'd have a few bacteria and germs up there to decay. So I think that is how you explain the half-decayed vegetation. We don't need a quick freeze for it, but we need a moderate freeze, and I think that happened by these strong, powerful cold fronts. What about the broken bones? Well, Larry Eigenbrod describes a sinkhole that's filled in with windblown sediments at Hot Springs, South Dakota, where they claim there are about 100 mammoths there. Most of them are Columbian mammoths and some woolly mammoths. How many have been to Hot Springs, South Dakota, to where these mammoths are located? They're digging them out. You can see their bones. Hardly anybody. You need to do some more traveling. There's a lot of great things to see out there in the world. A lot of things that support the flood and the ice age, post-flood rapid ice age. Anyway, he noticed that some of these mammoths had broken limb bones, similar to some of the mammoths in Siberia. And he says that can only happen by two processes. And they're limited to two. Torsional stress, that's moving like this, as provided by trying to extricate a limb mired in mud, muck, quicksand, etc. And number two, which I think we can totally eliminate, trampling. I think in the sinkhole environment, you probably had many elephants fall into it, and you had probably trampling there. But out in the wilds of Siberia, it was too wide to have trampling. So I think that first one. So the limb bones can be broken by trying to extricate themselves out of blowing dust packing around their limbs, getting thick. They try to get out, they shatter their bones. So I think that can account for the broken bones, for the limb bones. Now, what about the pelvis and sometimes the ribs, the bigger bones? Well, I think I found out the answer to this from these two guys, these two Russian paleontologists. They say after burial in the permafrost, the organic remains could have shifted vertically within a wide range owing to their physical properties and the features of the permafrost environment. It is now known that in frozen ground, that's permafrost, bones and pieces of wood are sometimes shifted vertically by 10 to 15 meters, that's 30 to 50 feet, along the boundary of frozen ground and ice veins. I think those thick bones were broken after they're in the permafrost by shifting permafrost, faulting permafrost. So it looks like the post-flood rapid ice age can account for not only the mystery of the woolly mammoth's death, but all those subsidiary mysteries. And here's kind of a summary. Woolly mammoths are peaceful eating grass and buttercups. By the way, buttercups grow in Siberia today, so But a lot of the vegetation found in their stomachs comes from further south, but not buttercups. Buttercups are there today, but there's hardly any grass. But anyway, it was a grassland at that time, much different environment, peacefully eating. Suddenly a cold front comes through, wind picks up, the dust starts blowing, he turns his back, the dust starts packing around him. It increases and increases, he breathes it, dies of suffocation, he's stuck in the dust, and he tries to get out with his limbs, shatters his a limb, and finally he gets totally covered and ends up in a general standing position in the dust with a broken limb bone. And then more dust storms come and bury him even further until he's well buried. And the permafrost, which is that blue area there, as well as cold air from the air that comes down, the permafrost actually rises to meet him, and he ends up in the permafrost. And then the permafrost shifts, breaking the pelvis. So I think that model can explain all these mysteries. So the next question, I want to do some relevance here. What does this all mean? Well, first of all, we have a mechanism that can explain it. They can't. But why can't mainstream geologists see the importance of the loess? By the way, this is a German term but no one pronounces it in German. It's actually pronounced Lurs. But I'm going to call it loess because that's what people call it. It's windblown silt. You find it in the Midwest a lot. The Palouse country in eastern Washington is supposed to be windblown silt, but I only think the top of it's windblown silt. That's another story. Don't want to get on that rabbit trail. Why can't they explain it? It's because of their stretched out time scale. For instance, Verish, again, the top Soviet expert on woolly mammoths, says one important factor was the fall of loess on the cold, wet ground. However, this deposition could hardly have exceeded 2 to 3 centimeters, that's 1 inch, a year. He's very generous. And at that rate, it would take 20 to 30 years to cover a mammoth, during which time the bones and tusks would have been almost entirely destroyed by atmospheric processes. You see, just an inch would still destroy the mammoth bones and tusks, and they would not be well preserved. And that is extremely generous, but Dale Guthrie is more realistic. These large bones could not be preserved by a few millimeters of annual aeolian loess fall. He gives it a few millimeters, but millimeters about the thickness of a dime. So we'll say 2 millimeters a year. That's probably more reasonable. In fact, that's probably a great exaggeration. But regardless, he's saying that doesn't work because the preservation requires large quantities of reworked silt. You need huge dust storms, and you can get those at the end of the post-flood rapid ice age. They don't get them at all because they have a different climate, different environment. Everything's different by the uniformitarian model, and that's why they have trouble explaining this mystery. They cannot see because of their stretched out time scale. See, they know there's 100, 200 feet of silt along some of the river valleys, but if you stretch that out in a deposition over 1 million years, it's totally insignificant. But if that deposition of windblown silt occurs in, say, 200 years, it is huge, with huge dust storms like the Dust Bowl era. I want to conclude this. Time is not a side issue, but crucial for solving mysteries. Our short time scale is crucial for solving this mystery of telescoping all the windblown dust into a very short time can explain the features we see up there. In summary, a post-flood rapid ice age accounts for the lowlands of Siberia, as well as Alaska and the northern Yukon territory, not being glaciated during the ice age. It explains why mammoths lived in Siberia. Well, the winters weren't that cold. There was no bogs up there to slow them down and get them stuck. And grass is very rich, so there was an abundance of food in Siberia. Also, it explains why there's a mix of warm and cold climate animals. I didn't tell you about that. It's called disharmonious associations. It's typical of the Ice Age. You have a lot of warm climate animals and plants that lived with cold climate animals and plants found in glacial debris. Exactly what you expect with cool summers and mild winters. It also explains how mammoths and other animals went extinct. It explains all the Siberian mysteries. And in conclusion, reasonable explanations for many mammoth mysteries are provided by the post-flood rapid ice age. The ice age is a climatic consequence of Noah's flood. This supports the Bible and the biblical worldview, and is against the uniformitarian or present processes over millions of years alternative hypothesis. So we can answer questions with the biblical worldview. I thank you.